Hey, what's good, everybody? Guys, I hope everyone is doing well. I hope everything is going well in your lives. Guys, listen, today is the 17th. It's day one. Back to school, right? And the 17th of January 2024. So we're just gonna carry on with what we've been doing, and I hope you guys are ready. And today we're gonna be looking at I was hoping that we'd get some identities that involve what we call, compound angles, also double angles. So, but the textbook that I'm using, it doesn't seem to have that. All right, and what I'm seeing here is that we've got equations now. Okay, trig equations that involve compound and double angular identity. So, okay, yes. So we are looking at trig equations involving compound and double angle identities. Okay. Oh my goodness, identities. And I mean, the work that you guys did in grade 11, it's gonna come in very handy, okay? Because this is just a build-up from what you guys did in grade 11. So cosine squared theta minus the sine of theta minus 1 is equal to 0. So we need to solve this equation. And any ideas? Unfortunately, you guys can't talk to me, and it's such a pity. But you need to ensure that everything is of the same trig ratio. Can you see there's cosine here, there's sine there? We cannot solve. It's like when you want to solve a quadratic equation, and then there's x squared minus y minus 1 is equal to 0. This you cannot solve, ladies and gentlemen. You cannot solve this. So you either need to express the y in terms of x or the x in terms of y, so that we have common variables. To understand? So here we can't have both cosine and sine within the same equation if we really want to solve it. So what we are going to do is we're going to say, okay, we do know the identity for cosine squared. Remember the square identity? So cosine squared is going to be 1 minus sine squared theta, right? Minus sine theta minus 1 is equal to 0. And now we're getting somewhere. The plus 1 and the minus 1, they cancel out. So basically what we're going to be left with is sine squared theta plus sine theta. And the signs have changed because I've already just divided throughout by the negative. And then now we're ready to take out a common factor. Sine theta out, sine theta remainder plus 1, and this is just equal to what? 0. Okay, therefore sine theta is equal to 0, or sine theta plus 1 is equal to 0. Okay, now this becomes a general solution. Okay, now we need to find the reference angle, we need to find this and that. Yeah, it gets complicated. So sine theta is basically equal to -1. So now the assumption is that 0 If it's 0, it's positive. So positive first quadrant and second quadrant. Okay, and the reference angle is going to be what? The reference angle is going to be the arc sine of whatever that's here, excluding the sine. So we don't focus on the sine. So arc sine of 0, or you guys sine minus the 0 as per your calculator, and this is just going to give you a 0 degrees. So but we know it's within the first quadrant and the second quadrant, so theta is basically going to be equal to, in the second quadrant it's 180 minus theta. So 180 minus this is just going to be 180 degrees plus the period times k, 36 degrees k. This is the period for sine. We always attach this to the k, the period to the k, when we're dealing with sine and cosine. Okay, so remember to find the 180, I used the fact that in the second quadrant it's 180 plus theta, or theta is what in the first quadrant, whereby it's just 0 degrees. Okay, so 0 degrees plus 360 degrees k. Okay, that's the first part. So meaning that once you've established the sine here, okay, once you've established the sine, you need to then determine whether the trig ratio is in the first, second, third, or fourth quadrant. Okay, and that goes back to the cast diagram. By making use of the cast diagram, you can tell as to whether, okay, in the first quadrant, which trig ratios are positive, in the fourth quadrant, which trig ratios are positive, so on and so forth. So once it's positive, once sine is positive, you know for sure it's in the first. It's in the first and the second quadrant. Okay, so that's why I use the reduction formula, theta and 180 degrees minus theta. So the theta basically represents your reference angle. Remember, I've got the reference angle here, it was 0. So I just went on to substitute the 0 there, even there, the 0. So when you substitute the 0 in place of the theta, it doesn't make any difference. You're just going to get your 180 degrees plus 360 degrees k. Yeah. I mean, this is a bit complicated, but once you get it, hey, you got it. Right, so look, we are looking at this one now, and you can see that sine is negative. So we go back to the cast diagram. When sine is negative, which quadrants does it lie in? Which quadrants does sine fall under? And because remember when we said it's positive, it was in the first and second. So if it's negative, then it's in the third and fourth. Now in the third and fourth, you know the reduction formula, 180 degrees plus theta, and then 360 degrees plus theta. Those are like the reduction formula. All right, not plus theta but minus theta, because as soon as you say plus theta, then it falls under quadrant 1. So let's keep it simple like this. I mean, the reduction formula, nothing complicated. If you can just know theta 180 degrees minus theta, 180 degrees plus theta, 360 degrees minus theta, I mean, you can, you know, get away with reduction formula most of the time. Okay, so let's check. Okay, we've agreed that because sine of theta is negative, it lies in the second and in the third and fourth quadrant. Okay, cool. So now what we need to do is we need to find the reference angle. So reference angle is always equal to the arc trig ratio, whatever trig ratio that you're given. This time around we're given sine. If it was cosine, we'd say arc cosine. So arc just means that instead of just pressing sine, you're going to say shift sine. Do you understand? So arc sine, the absolute value of whatever number that's given here. Remember, when I say the absolute value, I mean if it's negative, make it positive. If it's already positive, just leave it as it is. In other words, we want the positive value of whatever number that is given, so which is just 1 in this case. Now, what is the sine of 1? I believe it's 90 degrees. Okay, you can confirm with the calculator. So shift sine 1, that should give you 90 degrees. So now that we've got our reference angle, we know that our reduction formula is 180 degrees plus theta. 360 degrees minus theta. So meaning that the theta basically represents our reference angle. Okay, so theta is going to be 180 degrees plus reference angle, and you know you always need to attach your 360 degrees k, for as long as you're dealing with I forgot to say k element of z. I don't even know if this is called max, but it's just standard procedure. Plus 360 degrees times k. Okay, also theta is equal to 360 degrees minus the reference angle, which is what we just found here, plus 360 degrees k. Okay, so then we substitute our reference angle. So theta is going to be equal to, when you add 90 to 180, that becomes 270 degrees plus 360 degrees k, where k is an element of z. K is an integer. So even if we go to this one, it's still going to give us 270. So we're just going to leave it as it is. Okay, because it's just repeating itself. So these are the two general solutions. These are the two general solutions. Okay, not 2 but 3. We've got 180, we've got 0, we've got 270 degrees. So these are called general solutions because you can use them to find solutions at any x value. For instance, when you substitute the corresponding values of k, remember k is just the different y values from minus infinity to positive infinity. So if you keep on substituting the k values here, and then you get the different corresponding values of theta. Okay, which happens to be our x values, the theta values. Okay, now let's look at a slightly different problem. So we are now given the sine 2x. Sine 2x is equal to the 2 cosine of x. Alright, so now we need to simplify. And the general rule, once again, remember this side I said you must make sure that you've got the same trig ratios. Okay, you can't solve a trig equation where there's a cosine of theta, sine of theta within the very same equation. It's just not possible to solve. Now another general rule is that you cannot solve a trig equation whereby there's double angles, there's single angles, there's this and that. There has to be what do they call it? There has to be regularity. In other words, these trig ratios, they need to have angles that are similar, in a sense that you mustn't have double angles, triple angles, quadruple angles, this and that. No, you mustn't have that. So you must try by all means to get rid of the double angles if you can. Okay, if you can, because remember, you've got your compound, angle identities that you can use. You've got your double angle identities to get rid of these. Do you understand? So we know the identity for this double angle. So it's just going to be 2 sine x cosine of x. X equals to 2 cosine of x. And then you can see that the angles are now, even. That's the word I've been looking for. The angles are even because it's x here, x over there, x over there. There's no double angles anymore. And when there's, such a case, it becomes, very easy for us to solve. Okay, because we start seeing common factors. Can you see that there's cos x over there, there's cos x over there, so you can divide throughout by 2. So sine x cosine of x becomes what? Cosine of x. You don't divide throughout by cosine of x. You're gonna lose some of the solutions. So you factorize. So we take the cosine of x there to the other side, or you can take this whole thing to the other side. It's all up to you, really. Cosine of x minus the cosine of x. The most important thing is that whatever you take to the other side, it needs to change its sign. So let's factorize. Cosine of x, sine of x minus 1 equals to 0. Factorization, that's grade 9 work. So now we're ready to set everything equal to 0. So cosine of x is equal to 0, or the sine of x minus 1 is equal to 0. So simplify here, sine of x is equal to 1. Alright, so now we're ready to proceed. Okay, so remember what I said. If it's 0, the assumption is that it's positive. So in which quadrant is our cosine positives? Let's go back to the cast diagram. Cast diagram. You can see that cosine is positive in first quadrant and the fourth quadrant. Now what are the reduction formula for that? This is just theta. This is 360 degrees. 360 degrees minus theta. So let's go right ahead, and so we know that these are the quadrants that we're going to be dealing with for cosine. Let's go right ahead and find the reference angle. Okay, remember reference angle? That's the arc of whatever trig ratio that you're having of the absolute value of whatever number that's here. So reference angle is going to be the arc cos of the absolute value of the number that's there. Absolute value meaning that you get rid of the negative if it's there. If there's no negative, then no problem. You just plug in that number. And this is just going to be 0 degrees. So that's the situation right there. And now we're going to use our reduction formula, 360 degrees minus theta, and just theta. So theta is going to be 360 minus the 0 degrees. We know the period for cosine is 360, so times k. Or theta is going to be just the reference angle, which is 0 degrees, plus 360 degrees times k, where k is an integer. Alright, so we're done with this one. So let's move on to the other side. So now we're looking at 1. So remember, this is positive. Alright, this is positive, this number here. And if it's positive, we know the sine of any angle is only positive in the first and the second quadrant. Okay, first and second. So we already know that the reduction formula for first quadrant is just theta, second quadrant 180 degrees minus theta. So cool. Now check. we need to find the reference angle. So reference angle is equal to the arc sine of the absolute value of whatever number that's here. Absolute value of 1 is just 1. In other words, if we get rid of the sign, it just becomes 1. All right. Now this should give us 90 degrees. Okay. All right, that's fine. We've got the reference angle now. So remember, now that we've got the reference angle, we just use our reduction formula, which is the 2 theta and 180 degrees minus theta, because that's where, you know, sine lies in, you know, when it's positive. So theta is equal to what? 180 degrees minus 90 degrees. The period for sine, that's 360 degrees times k. And right, that just becomes what? 90 degrees plus 360 degrees times the k. Or our theta becomes equal to just a reference angle, which is this case here. So 90 degrees plus 360 degrees. Okay, so the solutions are the same, so we're just gonna, you know, keep one, but we know that k is an integer. So that is that, ladies and gentlemen. I mean, it gets there's quite a lot of problems that, you know, I can actually go through, but I feel like we should just leave it right here. Next time we're just gonna carry on with these problems, especially ones that involve the compound, you know, angle identity. But for now, let's just call it a day, and peace out.